All right, what's on the bench? We have these little things. We'll call it the thing of the day. They're not really chips of the day, but they're things of the day. And the first glance, you might think, well, they must be some type of capacitor. They're about, 10 millimeters across, leaded devices. Through hole, they, well, let me show you some close-up pictures here in the microscope. And so they look like solid material. They look like they're ceramic almost. And they're both the same size, it seems. And they both have nothing in the middle and metallization on the two ends. One is marked, the other has no markings at all. I have been unable to get any information on the TDK number, but TDK might be a clue, although TDK seems to build everything. So maybe that's not such as much information. So, what are these little guys? They're slightly different color, just very, might be lot to lot variation or something. I don't know. They look to be about the same, okay? So give me your guesses. What do you think they are? All right, I had a guess when I first saw them, and we'll see if I'm right. All right, so I believe that they were maybe thermistors, some type of thermal sensing device. They didn't quite look like capacitors. Let's go ahead and put one on a tester. Let's see, what's a good tester? Oh, I'll use my new tester. Got this really big ass tester here. We have to zoom out because it's such a big thing. All right, we can put in the device under test. Let's stick that in there, and we'll go auto. Run, okay. Oh, there we go. Run, or auto, I guess. I don't know, I haven't used this thing very often. Under test, measurement. Okay, it's a resistor, 1.3K. Okay, that's pretty boring. Maybe it's a real high precision type of resistor. That was a pretty accurate number of 1.3. Let's put in the other one. And auto again, I guess. And a resistor, 842 ohms, 842 ohms. Okay, so the resistors, I guess, of some type. Maybe not. Maybe this thing's lying to us. Maybe they appear to be resistors, but maybe that's not their main goal in life. They wanted to aspire to be something else in life. So let's get out a multimeter. Let's see here. Let's back up a bit. And all right, let's go ahead and turn on the ohmage, and we'll hook this guy up. Took this guy up. All right, now which one did I grab? I grabbed the 1.27 k ohms. So they seem to be a resistor. I'm going to go ahead and warm this thing up with my fingers, and it is changing. Let me get out a hot air station here. We got my hot air blower here. And we are going up. We're going up. So when it goes hot, the resistance increases, okay? So that is a positive effect when the increase in capacity or increase in resistance with temperature would be a positive temperature coefficient. Okay, positive temperature coefficient. And so they must be, oh, you didn't see that, did you? I got to turn the lights on. Can you see that? All right, let's do that again. Now that you can see what's going on here. Okay, I'm gonna heat it up. There you go. You can see it go up. All right, so positive temperature coefficient thermistor, is it a thermistor? It's a thermal sensor. We'll call it a thermal sensor because I don't think it's a thermistor. The way it's constructed, it looks just like it's a bulk material whose resistance changes with temperature. That's all I can kind of determine out of this thing. All right. So, yeah, positive temperature. Sometimes those are used as inrush current things into power supplies and stuff, but they usually don't look like this. They usually look round. They usually look like a round ceramic type of thing. And just for fun, we'll measure the other one. I'm sure the other one's just the same. And this was the 800 ohm one. And we'll heat it up. And whoa, something's wrong. It's going the opposite direction. This one is becoming less resistive with temperature. So it is a negative temperature coefficient, right? So one's a PTC, one's an NTC. And they're both the same size. And one has no markings and one has a weird marking. And that's where the video ends. And that's where the comments begin. Comment below. What is it? Why are there two that look exactly the same but act completely differently? Why does one have 0 markings at all? I mean, it doesn't hurt to put a little ink on them, right? Why does this one have no markings at all? Why does this one just seem to have a date code? It's TDK, but it looks like it has a date code, 1980. Probably the 28th week of 1980 is that number. So yeah, why? Why? And why do I have them? What are they doing in my junk bin? Obviously I pulled them out of some piece of equipment, and I thought, oh, those are interesting. Probably thinking they were some type of weird capacitor or something. Anyway, I don't know. Anyway, there you go. Strange thing of the day, and lots of room for comments.